Hello, this is lesson 4, and we're going to look at all this stuff, how to use negatives, um, multiply, divide, bidmas, the order we do things. We're going to look at squares, cubes, estimating answers, estimating square roots, indices, rules of powers. Indices will become apparent when we do bidmas, rules of powers, powers of 10, and reciprocals. So there's a lot to get through this one. It might not actually be in the same order, but anyway, so using negatives, using negatives, right, negatives are a bit awkward. So first of all, multiply and divide. Yeah, now if we have 3 times 4, these are both positive numbers, but we don't put the plus sign, we just take it as read they're positive. That equals 12. If we had minus 3 times 4, then this is negative, this is positive. It still equals 12, but it comes out to a negative. If we have 3 times minus 4, it's going to come out as negative 12. And negative 3 times negative 4 will equal positive 12. So when the signs are the same, two pluses, we get a plus answer. When the signs are the same, we get plus, and the same down here. Same signs, plus answer. Different signs, we get a negative answer. And that's all there is to remember. Same is positive, different is negative. And the same goes when we divide. So if we have 20 divided by 5, 20 over 5, I'll write it this way. They're both positive, so we're going to get a positive 4 as an answer. If we get minus 20 divided by 5, they're different signs, so we get minus 4. 20 divided by minus 5, different signs, minus 4. Minus 20 divided by minus 5, same signs, positive 4. Next part, bidmas. Bidmas is the order in which we do the calculations. I'll explain what that means. So if we had 3 plus 4 times 5, we could go 3 plus 4 is 7, 7 times 5 is 35. But if we did it the other way around, we do 4 times 5 is 20, 20 plus 3 would be 23. So we have two answers. Which one's right? Bidmas will help us. B stands for brackets. Anything that's inside the brackets, get rid of. Next thing is something called indices. Now indices is when we have, I'll use an X, is when we have a little square or a cube, that's an indices, or a square root or cube root, that's also an indices. So once we've got rid of any brackets, we look for indices to get rid of. And the others are nice and easy because that's divide, multiply, add, and subtract. So let's look at this one above, the 3 plus 4, 3 plus 4 times 5. And we've got an add and a multiply. And this, if we go down, 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 yeah? Brackets, indices, divide, multiply. So we have to do the multiply before we do the add. Because it's before, multiply is before add in the list. Yeah, so we do the multiply, which is 20, and then we add the 3. So the correct answer there is 23. 35 is not right. Yeah, that's bidmas. And this can get as complicated as you like. We could have 2 plus 4, and then if we have a bracket, a number, let's do 5, yeah? A number next to a bracket means multiply. We don't put that sign in either. We don't put the plus in, and we don't put the multiply. So yeah, so bidmas. So the first thing we need to do is get rid of the brackets. So this is 5 times 2 plus 4 divided by 8 minus 2. So if we get rid of the brackets first, so we will have 5 times 6, 8 minus 2. And 5 times 6 is 30. 8 minus 30, not 36. 8 minus 2 is 6. And 30 divided by 6 equals 5. So that's how we do that. We must follow things in the right order, no matter how complicated it seems. So let's have a look at this one. So we've got 3 plus 22 times. Sorry everybody, that's a bit messy. Let's make that nicer. And we're going to do times 3 minus 14. So it does no harm just to write bidmas in the corner so that you can remember what we're doing. So what are we going to do? Brackets, there aren't any. Indices, there aren't any. Divide, there isn't. Multiply is the first thing to do. So 22 times 3 is 66. And then we've got the plus 3 there and the minus 14. And then we do the add. So that becomes 69 minus 14, which is 55. Do things in the right order and we're absolutely fine. So let's have a look at this last one of this. So here's a huge square root sign. I'll explain what square roots are in a second. 4 plus 6 times 12 minus 2. So everything is square rooted. Now, if we go bidmas, the indices, we've got brackets in there, and then we've got the indices. But the problem is that if we do this bracket first, which is 12, so we've got 4 plus 6 times 12 minus 2 is 10. We can't actually do the square root until we've done all this. So what do we do here? We've got a multiply comes before the add. So that will be 64. That will be 60 plus the 4. So we've got 64. Now we need to find out the square root of 64, and the square root is a number that multiplies by itself to make 64. So 8 times 8 equals 64. So the square root of 64 equals 8. Bidmas, yeah, the right way around. So that leads us on nicely to squares and square root. So a square is denoted by a little 2 at the top, that indices bit. So 1 times 1 equals 1. 2 squared is going to be 2 times 2 is 4. 3 squared, 3 threes are 9. 4 squared, 16. 5 squared, 5 fives 25. 6 squared is 36. 7 squared is 49. 8 squared is 8 eighths are 64. 9 squared, 9 nines are 81. 10 squared is 10 tens are 100. And 11 squared is 121. And 12 twelves are 144. So the square of 3 equals 9, the square of 7 equals 49, and so forth. So that's the squares. Now if we go back the other way, and we go the square root is a number times itself, which equals 1, which is 1. See, the square of 1 is 1, the square root of 1 is 1. The square root of 4 is going to be 2. 2 twos are 4. Square root of 9 is 3. Square root of 16 is 4. And the square root of 25 is 5. And so on and so forth, yeah, till we get the square root of 144, equals 12. Things to remember. Things to remember. Cube roots, cubes. Now cubes are with a little 3 on the top now. So this is going to be 1 times 1 times 1, which equals 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 27. 4 cubed, 4 times 4 times 4, 4 16s, 64. 5 cubed is 125, and 6 cubed is 216. So that's about as far as you need to remember for cubes. Cubed. So you can work them all out. I mean, if you have 9 cubed, I don't know what it is, yeah. You just go 9 times 9 times 9, yeah. So you can always work them out, it's no problem. So the cube root. Now, to differentiate between a square root and a cube root, we put a little 3 in there. So the cube root of 1 equals 1. The cube root of 8 equals 2. The cube root of 27 equals 3. Cube root of 64 is 4. Cube root of 125 is 5. The cube root 216 equals 6. So that's about as far as you need to remember with the cube roots. Now the next thing on this lesson was estimating. Now, when we've done rounding before, you do your calculation and you round your number at the end. When you do the estimating, you do this at the beginning. For example, if you've got $4.95, these are prices, yeah. So $4.95 plus £6 and 2. Yeah, it's too. You don't want to. If there were lots of numbers, this is too difficult. So you sort of round that up to a fiver, and you round that down to £6, and you think, well, yeah, I can do that, yeah. So you know that the estimate of those two added together is going to be £10.97, but £11 is close enough. So that's what we do with estimating. And well, they've got some examples here, but we can sort of think of some. So we got 4.8 times 8.2 divided by 9.3. So the thing about estimating, you make these numbers as easy as you possibly can for yourself. So always look at the bottom first, because if this comes out to be a different number, shall I call it 9? If I call it 9, right, let's see what happens. So this, I'm going to go 5 times 8, which equals 40 divided by 9. Now 40 divided by 9 doesn't come out very well, does it? Yeah, 5 9s, 4 9s, 33 9. Oh yeah, it just doesn't go into there properly, yeah. So yeah, 4 9s of 9, 18, 27, 36, yeah. So if we did 40 divided by 9, we go, well, that's 4, it's 36, we got 4 over 0.444. It's just not nice. So if you look at that bottom one, make it so that it can divide into that top one easier. So I'm going to call that bottom one 10. So we get 5 times 8 divided by 10, which is 40 divided by 10, which equals 4. Yeah, which is not bad. 4.444. That 4 will be a good estimate. So look at the numbers carefully and round them up and down, or estimate the numbers so that you get something that divides into, and makes life easy for yourself. That's all that estimating is. And you can estimate them in different ways where you get, let's have a look, where you can have a possibility of different answers. Yeah. So we looked at this one, didn't we? 42.6 times 12.1 divided by 7.9. Now, first of all, I'm going to make that bottom number 8. No matter what that is, yeah? 42.6 times 12.1. Now, 8. Now, we've got to make this something that is divisible by 8 fairly easy. So, we could do 40 times 12 divided by 8, which would give you 480 divided by 8, which will give you 60 as an answer. Or we could do 40 times 12 divided by 8, which is 42 times 12 that is divided by 8, or even 40. Will that go? 42 times 12? See, now the problem I've got here is I'm starting to do calculations, and this is going against the idea of what this is. 504. Now, is that divisible by 8? 504? Well, 6 eighths of 48 with 2 over and 3. 63. So yeah, so 42, 63. But you see how that was just a little bit more hard work? Yeah? This was better. Rounding this all the way down to 40 made that a nice number, that a nice number. That's the best way to go, rounding. Alright. Indices now. Right, so indices. Indices are those little things, you know, like this. So we're going to multiply 2 cubed times 2 squared. Now, what it is, 2 cubed is 2 times 2 times 2. 2 squared is 2 times 2, and we multiply them all together, yeah? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Yeah, but this could get really awkward if there were big numbers at the top. So what we do, the answer is 2, and we just add. So we add those numbers, 2 to the 5. Look, 1, 2, 3, 4, 5. And that's 2 to the 5. But this only works when you have same numbers. Now, when you have the same numbers, it's fine. But if you had 2 to the 3 times 3 to the 3, you can't do this little trick of adding. You'd have to go 2 to the 3 is 2 times 2 times 2, which is 8, times 3 cubed is 27. So you'd have to do 8 times 27. You have to do it the long way. 56 and 16 is 21. 216. Yeah, so this is this method where when you multiply, you add the indices. Works when things are the same, and this happens when you've got algebra. X to the 4 times x to the 3 would simply be x to the 7. 3 and 4 make 7. Y to the 9 times y to the 9 is y to the 18. Doesn't matter what y is, it's fine. Right, now, what happens if we've got a negative number, x to the 4 times x to the minus 2? You still add these numbers together, but by adding, you're really doing 4 take away 2. So that will be x to the 2. Good. That's how you multiply. No problems whatsoever. Dividing? Well, if you divide, you will subtract the indices. You just do the opposite thing. Now I'm going to write division as x to the 4 over x to the 2. So I'm going to write my divisions like this. So because then you get the indices underneath each other. So x to the 4, 4 take away 2 will be x to the 2. And that could be made more complicated by having y to the 7, x to the 4 over y to the 3 and x alone. Now what is this, x alone? When there is no number, we make the, because we, in maths they miss a lot of stuff out. When there is no number next to the letter, it means that it's a 1. It's just one of them. So the 7 take away the 3 gives you y to the 4, and the 4 take away the 1 gives you x to the 3. Yeah? So what? That's a funny number, yeah? So let's do this subtraction, and I'm going to use numbers and explain this power of 1. So if I do 2 cubed minus 2 squared, yeah, this is going to be 2 to the power of 1. What is this to the power of 1? Now 2 cubed is 2 times 2 times 2, 2 times 2 times 2, which is 8, and 2 squared is just 2 times 2, which is 4. 8 divided by 4 equals 2. So this is the same as this. Yeah? So 2 to the 1 equals 2. So the rule here is anything to the power of 1 is itself. Yeah? So anything to the power of 1 is itself. So we know that 2 to the 1 is 2, because we wouldn't write to the 1. 99 to the power of 1 is 99. Yeah? So we're not, if we had 3 times 3, right? So 3 times, we know that's 9, don't we? But if we did 3 times 3 to the power of 1 to the power of 1, we would get 3, add the indices, squared, which is 9. So anything to the power of 1 is just itself. Right, now let's explain the other one. Is if we have, let's say x to the 4 divided by x to the 4. So 4 take away 4 is 0. You must put the 0 in. You must put the 0. Now what is x to the 0? So let's put some numbers in. So 2, we'll go 2 to the 4 divided by 2 to the 4, which is 2 times 2 times 2 times 2, 4, 8, 16. So this is 16 divided by 16, and that equals 1. So does it mean that this is the same as this? It does indeed. Anything to the power of 0 is 1. 1. Yeah? So x to the 0 equals 1. 43 to the power of 0 equals 1. Y to the power of 0 equals 1. Anything to the power of 0 is 1. Right, so a power raised by another. Right, isn't it? So we've got 2 squared, and then we're going to put that in squared. Yeah, so 2 squared is actually 4, and then there's the second one, so 4 squared equals 16. So that's how to work that out. So what does that mean, raised by another power? This. Now there's a short way of doing this, is we multiply the powers. Multiply the two powers. So 2 times 2 will just be the 2 to the 4. 2 to the 4 equals 16. Yeah? So that's handy. So if we have x to the 3 raised by another one to the 4, that will simply be x to the 3 4s are 12. That's all we do, raised by. If you have x to the 3 raised by to the minus 2, oh, it will be x to the 3 times minus 2 is minus 6. So that brings us on to something called the reciprocal of a number, because we need to do this when we're dealing with negative powers. So the reciprocal turn it upside down. What does this mean? So we'll have the number and then the reciprocal of that number. So we have 3/4. The reciprocal, turn it upside down, 4/3. That's it, turn it upside down. If we have a whole number, how are we going to turn that upside down? Well, you've got to imagine that that's 3 over 1, because 3 divided by 1 is 3. So we will go 1/3. So a whole number goes into a fraction like that. And if we have a fraction where it's that way around, the reciprocal of that will be 5. So you've got to think about when you've got whole 1 over something or a whole number. Yeah, so the reciprocal is that. And we need that for this x minus 6. So x to the minus 6. To get rid of the minus, we use the reciprocal. So we go 1 over x, and then it changes to a positive number. So if we have 8 squared, yeah, we know that that's 64. If we have 8 to the minus 2, we use the reciprocal, which is 1 over 8, 2. Now we lose the negative number, and this will be 1 over 64. Yeah? Reciprocals. Oh, we've just got a little time to do estimate. Oh yeah, we estimate square roots to 1 decimal place. Okay, now the big list of square roots. We know that the square root of 25 is 5, and we know that the square root of 36 is 6. But we might get this. What's the square root of 30? It's going to be in between 5 and 6. So if you think, well, how far away from 25 is it? Well, it's 5 away from 25, and it's 6 away from 36. So it's sort of, we've got 25 there, we've got 36 there, and our 30 is more or less in the middle. So we'll estimate that that might be 5.5 or 5.4, something like that, yeah? So you're just thinking, where is it? So if we want to estimate the square root of 13, you know that the square root of 16 is 4, and the square root of 9 is 3. So this is going to be in between 3 and 4. So that's 4 away from 9, and that's 3 away. So it's sort of in the middle. It may be 3.5 is an estimate, or 3.6 6 because it's just a bit further away from 9. That's it, estimate. Last bit, powers of 10. Bonkers, this bit. Don't need it. So, let's have a look. 4 powers of 10 is the other way around, isn't it? Powers of 10 is the other way around. 10 squared. So 10 squared is 10 times 10, which equals 100. There's a little number 2 there, which means translates into 2 zeros. So 10 to the 3 will be 1 followed by 1, 2, 3 zeros. 10 to the 6 will be 1 followed by 1, 2, 3, 4, 5, 6 zeros. That's it. That's all the powers of 10 is. Okay, that's the end of that lesson.